Hello, explorers, and welcome to Reach the World's Explorer program. For 25 years, Reach the World has inspired youth to become curious, confident, and compassionate global citizens through virtual exchange. My name is Tim, and I am so glad you're joining us for today's live stream event. Today, we are reconnecting live with Kelsey and the Cleanest Air on Earth expedition, both of which are still currently at sea in the Southern Ocean between Australia and Antarctica. We're going to find out more about exactly where. I know that's a big area I just described. You've read Kelsey's amazing articles at reachtheworld.org. I've added the link to her journey homepage in the chat if you're watching us on YouTube. And now we're traveling virtually for an in-depth look at the scientific fieldwork she and her colleagues are doing aboard the Australian research vessel RV Investigator. Welcome to the teachers and students who are joining us live today or will be watching this recording after the fact. I have a couple special shout outs to give. We've got Lawn School in Rhode Island. Hi, Lawn School. Cleanest International Academy in California. St. James School in New Jersey. Palmer Public School in North Carolina. Toluca Lake Elementary in California. Ensign Elementary in Utah. Cool School Canada. Creative Academy in Nepal. Saltbrook School in New York, Homeschool Friends in Massachusetts, and the Aquinas International Academy. Welcome to you all and to all others who are joining us for today's special event. For those of you who are tuning in live via YouTube, please make sure and feel free to use the YouTube chat bar to let us know you're here, where you're joining from, and of course, to share any questions you have for Kelsey as we go. We'll get to as many questions as we can in the next 45 minutes, but we have a lot to cover and a lot to see today. And without further ado, I am going to bring Kelsey onto the stage. Hey, Kelsey.
Hello.
How are you?
I'm doing good. How are you?
Good. It's great to see you. Before we sort of dive into the science today, we're getting really in depth with science today, which is really exciting for both me and lots of the students who are following. Can you tell us roughly what time of day it is where you are? I know there's lots of confusion about the big time zone difference between where you are and where we are, most of us in the United States.
Yeah, so right now it's 10:02 p.m. my time. So almost bedtime.
All right, 10:02 p.m. on Thursday.
Yes.
And where I am in Chicago, it is 8:00 a.m. on Thursday. So you're almost a full day ahead of us still, but you have changed time zones.
Yeah, that's correct.
So you're on the move. Can you tell us about your time zone change?
Yeah, so we changed time zones twice along the coast of Antarctica. So Australia roughly has 3 time zones in it, and we went like the full distance across all of those time zones. And now we're in Perth time, which is on the very far western side of Australia.
All right, great. So we're still a long way away from each other, but you seem to be getting closer in some respects. So great to have you here today. Thanks for joining us. I have lots of questions, both from myself and from students, about what you've been up to over the last couple of weeks, but I know that we've got some exciting science techniques and tools that you want to show us today. You're in a different location than we saw you last time. Maybe you can tell us where you are and what we're going to be looking at today.
Yeah, so right now I'm in the Clean Wet Lab on RV Investigator. This is one of 3 or 4 labs that we have on board, and this one we have some sea spray generation happening. So Mark is going to show us that in a minute. And then we also do some filter processing and seawater sample processing in this lab. So this is where we are today. This is our atmospheric lab bench, and we share the lab with another team. That's the carbon team. That was Lavi who just walked by. She's on that team. So
it's really cool to see in the background that there are other people clearly doing active projects right now at 10 o'clock at night aboard the ship.
Yeah.
And I think maybe you're ready to get going. So I'm going to turn it over to you and Mark.
Yeah. So are you ready to? So Mark, one of my coworkers, he works with the sea spray generator here. This is Mark.
Hello, everyone.
And he's just going to tell us a little bit about the setup and give us a demonstration of how it works.
All right. Have you told them about sea spray aerosol?
No,
Yeah?
Go for it.
What about aerosol?
I think maybe give us a refresher.
All right. So on the in the atmosphere team on this voyage, we're very interested in little particles in the air that we call aerosols. If you think of like a human hair, these aerosols are only a fraction of the diameter. You can't see them in the air really, but they're all around. Like in a small little volume here, there's probably a few hundred or a few thousand of these particles. And they're very, very important in the climate because every single cloud droplet you see in the sky starts with one of these aerosol particles. So when you got water vapor in the atmosphere, that water vapor condenses onto the aerosol and it grows, and that's how you get a cloud droplet. So down here in the Southern Ocean, there's not many sources of these aerosols, but there's one very, very important one, and that's the ocean itself. And all the waves that crash in the Southern Ocean produce bubbles. And when those bubbles rise to the surface, they pop and they eject out these little aerosol particles that are mostly made up of sea salt. But all around in the Southern Ocean, there's these little plant-like creatures called phytoplankton. From space, you can see them, they're green. And the sea salt can actually be coated with some of this biological material. And that can actually change how effective these aerosols are at being cloud seeds. So it's very hard to actually study that in the atmosphere because you don't know if the sea spray has come from the bubbles just in front of the ship or from hundreds of miles away. So what we're doing is we're doing a little experiment in the lab here. It's very messy and complicated, but it works. So in this little box just here, this is what we call our sea spray generator. And what we're doing is we're actually bringing water from outside the ship, sucking it through. We're putting it through this, in Australia we call this an esky.
It's a cooler.
A cooler.
Yeah.
Okay, I like esky more. So that keeps it at a constant temperature, which at the moment is 7 degrees Celsius, which is what, Fahrenheit?
I don't know off the top of my head.
It's very cold.
Very cold.
Yep. And then we've got a little pump that shoots the water into the top, and that sprays down and creates our bubbles. And then out of the top, well, the bubbles create our sea spray aerosol. And then out of the top, in these tubes here, we go off and we measure a whole bunch of different things. So Kelsey's got a little filter holder here. Did you want to explain what that does?
So this is a filter holder for INP, or ice nucleating particles. That's for the aerosols that are good for forming ice and snow in the atmosphere. That's what that's collecting. And then we also have this little monitor, which tells us the amount of air that's passing through that hose right there. So.
Then over here we've got another filter, and that just tells us what the aerosol particles are made up of. So, like I said, a lot of it's going to be sea salt. So, when you put salt on your dinner, we'll see a lot of that, sodium chloride. But then we'll also see all these organic materials from the phytoplankton that's in the water itself as well. But that amount of organic material will change if we were in a big bloom of phytoplankton outside versus a relatively dead area. The amount of organic material will change. So that's what we can find out with that filter. And then we've got two more instruments here just behind Kelsey. And this one here, that actually makes a cloud inside it. So all the aerosol particles, the little sea spray particles, they get exposed to a lot of water, and you make a little cloud, and then we count how many cloud droplets are formed. And then this little instrument here, that just tells us how big the particles are. And so that's the sea spray experiment.
All right, fascinating. Thank you so much, Mark, for joining us and helping us understand that. I have a couple questions if you have like 2 or 3 more minutes on behalf of the students who are watching, first of all, the idea that you can create your own cloud in a box is kind of amazing. Like if we opened that box, would there be a little puff in there? Is that what you're talking about?
It's quite difficult to see, but actually there is a fun experiment that we've done down here where, because we're in the Southern Ocean, the air is extremely clean. And there are times where there are basically none of these aerosol particles in the air. So we walked outside with a little cup of like boiling hot tea. And normally if you're carrying around a tea, you can see the steam. That's actually a cloud that you're seeing. You've got aerosol particles in the room, and the water from the tea is condensing on that and forming a little cloud. But if we go out the front of the ship where it's extremely clean, it doesn't look like it's boiling at all. You see absolutely nothing. And then if you get like a little lighter and introduce some smoke particles, straight away you can see the cloud form.
Amazing.
Yeah.
I know that this expedition is in this particular part of the world because the air is so clean.
Yes. Yep.
Is this work something that you have to go to this part of the world to use the sea spray generator, or the data you're collecting from this particular part of the world? Why is that so valuable to you?
Yeah, so there's a few things that we're doing on this voyage. I'm sure Kelsey's run through it. This is just one activity. Measuring what's actually happening outside right now, that's extremely valuable. We can't get those measurements anywhere else. They're very, very important because the air out here is kind of the closest thing to the atmosphere before humans started putting all of our pollution up into the atmosphere. So understanding what the atmosphere is doing down here tells us what the atmosphere was doing a few hundred years ago. So that's why we have to be out here measuring the air. But for the sea spray tank, it's pretty hard to collect water samples and then bring them back and then do this later, because the biology is so dynamic. The phytoplankton can die, or new types of phytoplankton can grow, and then it's not representative. So right now it's only a couple of minutes between the water outside and in the lab, and that's not enough time for the biology to change. So it's a true representation.
Gotcha. And one last student for you. We'll let you get back to your work, or from our students. Is the sea spray generator operating all the time, around the clock, or do you take measurements at different points of the day?
It's a good question. So for the first month of this voyage, it was not up and running at all. It took us a long time to get it working because we've got just so many things happening. But now we have it basically running non-stop. So right now it's sampling water from outside. We're actually doing another experiment as well out on the front of the ship. We've got two giant tanks that have a lot of water in them. Mm-hmm. And we're doing a little experiment where we're adding an element called iron that phytoplankton really like. Mm-hmm. They need it to grow. So we're doing an experiment where we add iron and we just see a big bloom happen. So I'm also taking water, Kelsey and I are taking water from there every day and putting it in this and seeing what that experiment will do to the sea spray aerosol.
Okay.
Well.
All right. Well, I said that was the last question, but then a student dropped a question in the chat that I have to ask because it's so good. Could you create snow from the cloud in the box?
Could you create snow from the cloud in the box? No, not yet. I mean, you could if you had a good setup. If you had a really cold room, then you could create snow. Yeah. But not in this lab. It's too hot in this lab.
All right. Amazing. Yeah. Mark, thank you so much for showing us that and explaining.
No worries. Thanks, Tim.
Yeah, great to meet you. Yeah. All right. Amazing. Kelsey, the sea spray generator. We've heard about it. Now we got to see it in action.
Yeah, exciting.
Can you tell us, you mentioned at some point that you have a couple filters and special instruments along the path of the sea spray generator tool. What are you looking at on a daily basis? The filter that you pointed out before, what do you have to do anything with it? Are you taking measurements? Are you taking something off of the filter? How do you interact with it?
Yeah, so the filter we were showing before, we swap it out between each experiment we're doing. So for the different tanks that are on the front of the ship that Mark was talking about, we're running those samples for about 3 hours. The underway water, so the water that's just outside the boat that we're sampling all the time, we run those overnight. And what happens when we swap out the filters is you can unscrew the filter unit that's attached to the line and remove like these little filters. And those I put into these Petri dishes, which are just little clear dishes. And those will be processed later by the person that we're collecting these samples for. So we're collecting them for someone who works at Colorado State University, Jessie Cremian, and she'll process those all later.
Okay, great. Question from the chat. Do you do any sort of radioactive dating of your samples? Do you know, is dating the materials any part of your work?
For me, no. I don't think anyone in the atmospheric team is doing anything like that. There is some operations on the boat where they do look at super old water, like the water that's upwelling from the bottom of the ocean along the coast of Antarctica. So that's kind of the oldest stuff, and they can date that back, I think, but I'm not sure. Yeah.
Okay, great. Well, we wanted to talk a little bit. You and Mark are obviously doing atmospheric-based research, data collection through your work. There were a lot of questions in our student community about whether it's like just you two on the boat, or like who else is doing work on the board? Is everybody looking at the atmosphere? Can you give us sort of an idea of, you mentioned that you share the lab with another team, for example.
Yeah, so on board, we have 5 different atmospheric scientists. So me and Mark, and then 3 others. And then there's also 4 other teams besides the atmospheric science team. So those teams, most of them are oceanographers and study stuff in the ocean. So it's the atmospherics team, the carbon team, the trace metal team, the physical oceanography team, and the biology team. And each of those teams look at different things. So we're looking at the atmosphere, the weather, the aerosols, the clouds. The carbon team looks at carbon in the ocean, and they can use that to look at carbon processing. And then the biology team is looking at like the zooplankton and the phytoplankton, which are those little plants and very small animals, very small fish that are in the ocean. And then the physical oceanography team is looking at basically the physical attributes of the ocean at different levels. So they're using the CTD, which samples water from multiple different levels. And then, the trace metal team is looking at trace metals. So that's basically just looking at the metals that are in very small amounts in the environment, and those can tell you different things about like biological processing and stuff like that. I don't know the total details of that, but there's my brief synopsis.
So that sort of raises the question, when you're all hanging out together at mealtime or in the lounge, and you all have your own special interests and specialties, things you're looking at as part of this expedition, what do you talk about? Do you talk about what you're finding? Are other groups interested in what you're doing? Do you talk about the different things that you're doing, or do you just not talk about science and you just relax for a little bit and then you go back to your separate work?
So yeah, there is a lot of interdisciplinary work on board, which basically just means the team's working together, which is really cool because then you get to know everyone else's research as well. So like some of the people that we collaborate with like on a daily basis is the biology team with the tanks that we're collecting water from on the front of the ship. We're sampling at like the same time as them. And we're both interested in looking at the different processes of the biology in the tanks and what that produces both in the water and in the air in those tanks. And then, yeah, we find a lot to talk about at the dinner table. A lot of it is talking shop. A a lot of it is talking about the different things that we've seen throughout the day. And a lot of it is just not related to work at all, for sure. Some of it's just about like our favorite foods, what we like to do in our spare time, different events. Like I was describing Groundhog Day to them a few days ago, which is not something that's celebrated in Australia and is kind of an odd topic. So yeah, that was a good dinner conversation.
Excellent. I know you're on an Australian research vessel. Does that mean most of the other people on the ship are Australian?
Most of the people are, but it is like a fairly international group. Like we have people on board from Germany, Argentina, and yeah, kind of all over. Yeah.
All right. Well, I know you've got a couple other things on the table in front of you that you wanted to show us, so I'll turn it over to you.
Yeah, so I wanted to kind of show you what it looks like to get ready to do some work in the lab. One of the things that we have are these lab sleeves, and these just help us stay like sterile in the lab. So the IMP that we're looking at, those are really easy to contaminate. And so one of the things we do is make sure we wear lab sleeves that look like this. And then we'll put gloves on top of that. So this is kind of what that looks like. And then I'll put on gloves, lab sleeves whenever I'm collecting samples or swapping out filters or anything. So once you have that on, that's kind of the setup. And then I brought in one of the old filter units for the air samples that we have outside. And this is what those units look like. There's a little tube that will attach to this inlet here, and then it just pumps air through this unit. And it has a cover over the top of it, so it's protected from rain and snow and any moisture from the ocean waves or anything like that. So what I do is I bring in this sample unit from outside. I pop it open, and up on top here, we have, this is the backing filter. So this is not what we collect, but normally there will be another thin filter on top here. I collect that sample, put it in a petri dish, and send it back to the States for later sampling. And all of this is done with like tweezers. All of it's done in a hood. So we try and reduce contamination as much as possible.
Kelsey, sorry to interrupt, but can you hold that a little bit like higher up to your right?
Oh, yeah.
It's just like off the bottom of the camera. There we go.
There we go.
Thank you.
So that's what it looks like. And this top comes off like that. So you can see that it's open. And then when I'm sampling, I take that off. And we can see this is the backing filter that we don't collect, but normally there's another one on top of that. And that's the filter that we collect.
All right. When what you're trying to collect is essentially invisible, is it hard? I mean, some of the other teams are collecting, biology, like you have a fish or you don't have a fish. Is it hard for you to know that you're collecting the right thing?
Yeah, I think that is one of the difficult things because we don't really know what we have until months down the line after this voyage. So it's kind of just, we're doing the best we can to collect all of the samples we can and collect them in ways that contaminate them the least. And then, yeah, we'll just see what we get. It is kind of fun because one of my jobs is to filter some of the seawater samples. And to do that, we push a bunch of seawater through this little filter. And I was really excited one day because the filter actually had like green dots on it, which was fun to see. That was maybe the only sample that I've collected where you can actually tell that something happened, but that was a fun day.
All right. Yeah. Can you talk, when you collect samples on the ship, you mentioned that you don't necessarily analyze them while you're on the voyage. Can you talk a little bit about what you're collecting and what happens to it after this voyage is over?
Yeah. So what I'm collecting is just the filters for the air that we're sampling on the fifth deck. And then I'm also collecting filters on this sea spray generator, and I'm collecting some seawater samples. So for that, we're just preserving a little bit of seawater. We preserve this much seawater, which is 40 milliliters. It's just a really small bottle. So that is going to be used for ice nucleating particle studies later on. And then we're also collecting DNA from the seawater. And that just looks like collecting some more little filters that we're pushing seawater through. And then later on, this is all sent to Jessie for further processing. I don't know exactly what that process looks like, but we basically hand off the data to her at that point. The stuff that I work with on a daily basis is the remote sensing data, and so that's all of the data from the radar, the microwave radiometer, all of the equipment that's on the fifth deck of the ship. And that data we actually see coming in real time. So that is a little reassuring that we are collecting some data. But yeah.
Great. Well, I'm making a mental note that we need to, when this voyage is finished, we need to connect with Dr. Jessie Cremian and hear from her now what she's doing with the samples that we've seen you collecting, which is cool to see the whole process. You wanted to take us on a little walk and show us something else, and we're going to try it with the connection, and if it works, great. Well, let's go for it and see how it goes.
Okay. So, sorry, okay, I'm still here. So this is our lab. We're leaving now. And then I can try and show you kind of what it looks like to walk down a hallway here, if this is going to work. But we're walking out the door. This is like a hallway, and you can see there's some doors. If we walk through this door,
All right, I think it may just take a minute.
Continue down this hallway. We make it to the other lab that I work in, and this is our dirty wet lab. There's lots of storage here. So you can see all of the benches basically are filled with these boxes, and in each of those are floats that the oceanography team uses. This here is our setup for the radiosonde launches. And I wanted to show you the equipment that we use for those radiosonde launches. So what I have here is one of our radiosondes. This one, the battery is dead on it, so it's no good to use, but it's a great way of demonstrating what we're doing here. What we have here is a radiosonde. The radiosonde itself is made out of like styrofoam, and it has these two different metal pieces sticking off the edges of it. And this one here is the sensor that measures the temperature, pressure, and relative humidity as this radiosonde is going up in the atmosphere. So, and then this end is the antenna that communicates back with the ship. So what we do with these are we attach them to a balloon, and then we let the balloon go, and the balloon goes up in the atmosphere and collects a profile of the temperature, pressure, and relative humidity. And from that, we can look at different things like the cloud top height, the cloud base height, if there's an inversion, which means like maybe there's less mixing in the atmosphere, or it can give us information about where the aerosols are coming from that are forming those clouds. And so that is one of the tools we use. The balloons that we use for the radiosonde, they look like this. They're a meteorological balloon, and they're 100-gram balloons. So when they're blown up, they're about 2 feet across. And then on the end of the balloon, we attach one of these. This is called a winder, but it's just like a clip with a ring of string on it. And then the radio sonde will attach here. So it'll attach like this. And then the balloon pulls the whole thing up like this. And then it will unwind as the balloon goes up. And so that basically just makes a distance between this instrument and the balloon. So this can't swing around, hit the balloon, and pop it. So that's what we do here in the Dirty Wet Lab is we get everything ready for the balloon launches. Then we can walk right out that door that we saw in the hallway and launch a balloon.
All right, fascinating. It was fun to take a walk down the hallway and see a different area that you work in. I think for any student who works in a school laboratory, they can see some things in your background right now that may look familiar with them. There's sort of some safety equipment, an eye wash station. It looks like that might be lots of other scientific equipment around you. One of the questions for you is, we're in two rooms today, the wet lab and the dirty wet lab. Like, by name alone, what's the difference between a wet lab and a dirty wet lab? They both sound like things get messy in there.
Yeah. So this lab that I'm in now is the dirty wet lab. This is basically just where anything can be. There's no worry about how clean it is or any risk of contamination. So a lot of a lot of the biology is brought in here. Like if they put nets out and are collecting like phytoplankton, a lot of times those nets are brought back into here, the dirty wet lab. The clean wet lab is the other lab that we were in earlier today. And the clean wet lab is supposed to be for things that are wet, but you're worried about being contaminated by other things. So it's a lot of the seawater that we're looking at, stuff that is easily contaminated. So the carbon team is also in there. And then, we're doing the INP processing in there. We don't really need to be in any specific lab for the work we're doing. I guess it actually is good we're in there for the INP stuff. But we kind of found a place where there was space on the ship and used it. So
Sure, of course. Well, this has been an amazing overview of the science, and I know students are really, really interested to see and hear more about the actual science that you're doing aboard the ship. I have a bunch of questions here from students that they wanted me to ask you, and it's not we're going to move on a little bit past science because they have lots of questions now about your everyday life aboard the ship. And we can do sort of a rapid fire going down this list of questions. Gretchen was curious about whether it was challenging for you to change time zones so frequently.
Yeah, it was challenging a little bit. And it was kind of confusing because a lot of people on the boat work in shifts. And so that also meant that their shift time was changing. So there's normally a AM shift and a PM shift. And all of those hours got kind of swapped around by an hour every time that we changed time zones. But we figured it out.
Great. Ashlyn would like to know what interests you personally and made you want to go on this expedition.
Yeah, that's a great question. I'm really interested in precipitation and a lot of the cloud studies that we're doing. And I think on this voyage, I've seen some of the most textbook, perfect examples of what a cloud should look like and what precipitation events can look like. I think that's what made me interested personally. There have been a lot of amazing things that have stood out, though. Just being on the boat alone is really incredible, and working with all of these people is really incredible. And building collaborations with everyone on board is really cool.
Excellent. You just submitted and we published a great article about the wild weather in the Southern Ocean. And we were talking before we went live, and I think it relates to that question that not everybody on the ship is excited when a storm rolls through. Can you tell us who would be excited when it's stormy in the Southern Ocean on the ship, and who would not be?
Yeah. So basically, the atmospheric science team is probably the only people who are really excited when the weather goes bad. And that's because we're excited in the clouds that happen after big storms and big fronts pass through. And so anytime there's a storm that comes along, we're kind of celebrating and going, oh, please, can we get the clouds we want to see behind this storm? But everyone else is definitely bummed out by the storm because a lot of the equipment on board cannot be operated if there is a lot of big waves or high winds. And so a lot of times stuff is put on hold if a storm rolls through. So like in the last week, we had, I think it was 2 days where we couldn't do any of the science except for atmospheric science. And so that kind of put a damper on the mood. But now we're back to regular sampling and able to get a lot of the seawater samples and everything like that again. So
We can definitely tell from our view that you're at sea because the handle of the spill station behind you is swinging back and forth without anybody touching it, but it doesn't seem to be swinging too wildly. So is it safe to say it's a relatively calm day today by you?
Yeah, it's pretty calm, and we're also on station right now, which means that we're doing scientific operations, and that means the boat is basically sitting in one location, and the waves are basically coming into the ship. So the ship is sitting like this, the waves come like this, and the boat basically just goes like this, which makes everything really calm. When the boat really gets going is when the waves are coming in from the side and the ship starts to move like this. And that's when you start to see boxes flying around, and you have to run to make sure everything is strapped down into place and everything. So,
all right, excellent. Mason would like to know what responsibilities you have, if any, regarding the management of the ship, or sort of beyond your scientific responsibilities.
Yeah, in terms of management of the ship, it's kind of just we're in charge of the equipment that we bring on board. So making sure that everything is strapped down in bad weather, making sure everything is working as it should, making sure that there's no like worries about leaks in any of the lines or electrical problems or anything like that. And then we're in charge of like keeping our rooms clean. So there's like you're supposed to go through a list of items to clean every Monday. And so that means like vacuuming your floor, cleaning your bathroom, scrubbing out your shower, and changing your sheets. But yeah, besides that, there's some stewards on board who take care of the ship and make sure that the hallways are mopped and the trash gets taken out and all that. So yeah.
Wait, so you're saying that even when you're an adult and you are far from home in one of the most remote parts of the ocean in the world, you still have to keep your room clean?
Yeah, it's true.
That's going to be disappointing news, I think, for some of the kids who are thinking about going to sea. Landon would like to know, are you allowed to fish off of the RV Investigator? And if so, what's the biggest fish someone has caught?
Oh, wow. So we're actually not allowed to fish off the ship. It says before you get on the boat, you have to fill out a bunch of paperwork. And part of that paperwork says, I will not bring a fishing rod on the boat. But there are some samples that are being collected that are like the zooplankton. And so those are super small fish. The biggest one I've seen was maybe like that big. But a lot of it is like krill, which is what feeds the whales in the ocean. So it's cool fish, even if it's small fish.
Well, the Eagle Eye students amongst our group here have noticed there is a whale tail on the expedition logo, and there are lots of questions about whether or not you have seen any whales in the Southern Ocean.
Yeah, we really lucked out on the wildlife we've seen. We've seen a bunch of humpback whales, which are my favorite because they'll come out of the water and they'll bring their whole tail with them and show you their whole tail before they slide back into the water, which is really cool. And And then we've also seen some orcas down by the continent. That was super exciting, but you had to be really fast to go and see those because they would kind of like spook around the boat. Like they would hear the sound of the boat and then they would shoot off. And then we had a potential blue whale sighting, which is, I'm pretty sure, the biggest whale. And that was way far away, but I saw a spout from it, so we'll call it that I've seen a blue whale.
Very
and then
exciting.
we've also seen some pilot whales, which have been fun. If you see a pilot whale, sometimes they'll do like this thing that's called a spy hop. That's where they stick the head out of the water, like the head and shoulders out of the water, and just kind of like look at you, and then they'll go back underwater. So that was a fun sighting. Yeah, I think
Amazing.
That's all the whales
Yeah,
we've seen.
great. Well, I'm glad you got to see lots of whales. Gatlin would like to know, does the lack of sunshine and the presence of foggy and cold weather affect your studies?
Kind of, yeah. We had a long period of time where it was really foggy and not much was changing. And so we kind of reduced the amount of weather balloon launches that we were doing during that time, just because the conditions like looked exactly the same almost in every single balloon launch we did. And so we were really waiting for that time period to pass along, but we still continue to collect samples regardless of those kind of conditions. The only conditions we don't take measurements in are unsafe ones. So really big waves outside, really windy outside. But yeah, I would say when the sun comes out while we're out here, everyone goes outside and tries to soak up as much sun just to keep everyone happy on board. So
That makes perfect sense. McKenna would like to know, speaking of wind, does the wind affect how far you travel each day or where you go?
Yeah. So it does affect how far we travel because the boat goes less fast in bad conditions. So on our way down here, down to Antarctica, we had really good conditions in the first like 2 weeks of the voyage. And so we basically just like full steamed down to Antarctica. And we were going about 12 nautical miles per hour, which is about as fast as this vessel can go. And then in bad conditions, like really windy or big waves, or the waves and wind are going in different directions, which makes the whole sea state really like unpredictable, then we slow down a lot and we'll go like as slow as 5 knots per hour.
Okay.
5 nautical miles per hour, I guess.
Great. We've got 2 more questions, and they have a lot to do. I think some students have correctly perceived that you have been on the ship and away from your home for quite a while now. We have about 2 more weeks or so left to go in your voyage before you return to Australia and get to come home. Do you ever get bored when you're on the ship?
Sometimes I get a little bored. I think it is kind of hard to get bored when there's so much going on the boat all the time. And we do a lot of stuff to keep ourselves busy. Like right now we have a ping pong tournament happening. It's a pretty fierce competition. So everyone's pretty excited about that. And then besides that, we play like card games or board games, or we'll watch movies. I have never seen The Lord of the Rings, but now I've seen all 3 of the movies. So
it's a good chance to watch some of those really long movies because you've got some time.
Exactly.
All right, wonderful. And final question. I should say that last question was from Grace. Grace, thank you very much for the good question. And our final question today is from Kylie, who would like to know, do you get to decide when you want to go home and visit your friends or family?
Yeah, no, we don't get to decide that. When you get on the boat, you sign up for the amount of time you're on the ship for. So this one is, I think, 64 days. And we're all on the boat for that amount of time unless something goes wrong. So yeah, yeah.
All right. Well, 64 days is a long time, but you're a long way from home, and you're doing really, really cool work. So thank you, Kelsey, for showing us today more of your environment on the ship, certainly more of the science that you're doing, and the whole reason you went to this remote part of the world in the first place. It was super fun to reconnect with you. That's all the time we have for today and for this live stream event. But thank you to our entire YouTube live stream audience. Thanks to the students for these great questions. Definitely don't miss Kelsey's amazing articles that she's published on the Cleanest Air on Earth Expedition Journey homepage on Reach the World's publishing platform. I have put the link in the YouTube chat so you can check that out if you haven't already seen them. And we are definitely going to reconnect with Kelsey towards the end of the journey, maybe when she's back in Utah, so we can have a stable conversation on dry land and we can reflect on this journey that you've had. But in the next 2 weeks, Kelsey, before we go, what do you think the next 2 weeks are going to look like for you as you wrap up this the active portion of this expedition?
Yeah, so the next few weeks we're taking samples, kind of continuing on like normal until we get to Australia. And once we get to Australia, we unload everything from the boat, pack it up and get it ready for shipping, or we leave some of the equipment on the boat for another voyage that's going to happen. And then, yeah, I get to spend a few days being a tourist, and then I pack my bags and head home. But yeah, I'm looking forward to enjoying some sun in Australia before going back to Utah.
All right. Well, take lots of pictures for us. We want to hear all about it. Kelsey, thank you so much. I know you're staying up late to connect with us today, so get some sleep. Thank you so much, Kelsey. It was great to see you.
Yeah, thank you. Good night.